Hello everyone, and welcome to this video on evaluating the square root of negative real numbers. Alright, so we've seen in the past videos of mine that whenever we have an even root, right, a square root, a fourth root, etc., right, we always said that, the radicand, the number underneath the symbol had to be non-negative, because if it were negative, it wouldn't be considered real. And in the last video I put up, I did discuss the set of what are called the pure imaginary numbers, right, which we're going to see today that when you're taking the square root of a negative real number, what you have is one of those pure imaginary numbers. Right? So I have several examples, and where I'll refresh your memory as to what certain things are along the way. So let's get going here. So my first several examples, I'm asking myself to write each radical as a pure imaginary number. Right? So before I get into these examples, let me discuss again, hopefully refresh your memory as to what a pure imaginary number is. Right? So here off to the side, let's say recall that the pure imaginary numbers are this set. Right, the pure imaginary numbers are a set of numbers, right, where each number looks like this, where it looks like some number b, I know it's a letter, but it represents a number, times the number I. And I'll discuss what that is again. Hopefully, again, you remember that this is that imaginary unit I, the square root of -1. So every pure imaginary number looks like this, some number b times I, where b is a real number. Right, so some rational or irrational number times I is a pure imaginary. And again, remember this I is what they call it's the principal square root of -1. Right? You might see it symbolized like this as the square root of a negative, right? The imaginary unit I. Also, being the square root or the principal square root of -1 means that this is a number that when squared, right, I to the second power gives you a negative number, right? I squared would be the negative number, -1. Okay, so again, some quick examples of some pure imaginary numbers. Well, first of all, just the number I itself, right? That's 1 times I, a real number, times I. 2 times I, a real number, times I. The square root of 3 times I. Notice how I didn't extend the square root. The I is not inside the square root. So very often, just to kind of avoid the possibility of making that mistake, you might see like with variables, usually variables are thrown in front of radicals. We're going to treat I like a variable a lot of the time. So instead of the square root of 3 times I, you might see that written as I times the square root of 3, but they're the same, they mean the same thing. Pi times I, right, a real number times I, -3/5 times I, and so on. Right? I could make up examples all day long of these pure imaginary numbers. Okay, and then in a definition, you're going to have to remember to write the square root of a negative as one of these pure imaginaries is the following. Right? So, and I had this up in my last video on the complex number system as well. If we have a non-negative number, right? So suppose n is a non-negative number, right? It's greater than or equal to 0. Then when you see the square root, right? This is the square root of the opposite of this, right, of negative n. Right, so n is non-negative, but I put negative n, the opposite of n in this radicand here. So this is negative, right? This is a negative number, negative n. You can rewrite these as an imaginary, a pure imaginary number, as the square root of n, right? The square root of a non-negative number, right? And the square root of a non-negative number, that's real, times that imaginary unit I, times the square root of -1. All right, this is huge here. Or again, you could also rewrite them in another order. Instead of the square root of n times I, you can write it as, I first, I times the square root of n. But this is very, very important. I'm going to make a big note over here. I'll say whenever, and I'm going to do this every time, whenever you see the square root of a negative number, whenever you see the square root of a negative real number, rewrite it as a pure imaginary number. With that unit I. Okay? So back to my example, way back up here. I have the square root of negative 36, right? The square root of a negative number. So according to what I've written over here, I should be able to rewrite this as one of these pure imaginary numbers involving this imaginary unit I, this square root of -1. And the way that's done, if you see here, just basically the value of n is 36. The square root of -36 is simply going to be rewritten as the square root of 36 times I, right? And if you want the dot, fine. Or I times the square root of 36. And there we go. That's a real number, right? The square root of a non-negative, that's real, times this square root of -1 times this imaginary unit I. This is a pure imaginary number. Now, of course, as we've seen with all other radical videos I've put up, videos on radicals, please simplify. I'm going to simplify the radical. The square root of 36. Now, be careful, right? Remember, anytime you see this symbol, anytime you see the radical symbol with an even root, square root, fourth root, sixth root, etc., you're being asked for what's called, the principal square root, right? Or the non-negative one. So it's like, yeah, I know that -6 to the second is positive 36, but they want positive 6 here. Okay, when you see that symbol. So this is 6 times I, right? And again, there's a real number times I. There's your square root of -36 rewritten as, a pure imaginary number. And if you want to double check, is that truly the non-negative or the principal square root of -36? All right, let me check that down here. All right, pull these pages up a bit. So, let's check, is the square root of -36 equal to, 6i? And don't forget, I'm going to say this a lot. I'll write it here. Remember this simple means the principal square root. Right? Because as you saw with positive numbers, right, the square root of a positive numbers have, 2 square roots, 2 real square roots. Well, what you're going to see too is that negative numbers also have 2 square roots. but they're, you know, pure imaginaries where one has a positive coefficient and the other has a negative one. So, you know, principal, when you see this symbol again, this is the principal square root, meaning I'm going to have a, you know, a non-negative coefficient on the I. All right, so pay attention to that. Be careful with that. Well, let's see. Is this true? You know, is 6i truly the principal square root of negative 36? Well, if it were, that would mean that 6i squared would be negative 36. All right, so let's check that. Let's take 6i and square it and see if I get, you know, negative 36 back. Remember, this is 6i times 6i, and remember I said we're going to treat I like a variable in most cases. 6i times 6i would be 36 times I squared. All right, I times I would be I to the second. But remember earlier, right? Remember what I is, right? Remember I is the principal square root of negative 1, right? I is this number that when you square it, you get negative 1 back. So 36 times I squared would be 36 times negative 1, which is indeed negative 36. Great, it checks out. So 6i is the principal square root of negative 36, as we have stated up here. All right, so I'm not going to do this with every single example, but if you want to check is some number a square root of another number, just square that number. Do you get the radicand back? 6i squared is indeed negative 36. All right. I think the most important things to take away from this page here, these pages, one is that what a pure imaginary number is, right? Any real number times I, and what I is, right? This I represents the principal square root of negative 1, meaning that I squared will be negative 1. Whenever you see the square root of a negative real number, please rewrite it as a pure imaginary, right? The square root of negative n, where n is non-negative, but negative n would be negative. The square root of a negative is just the square root of the non-negative number times the imaginary unit, right? Some real number times I, a pure imaginary. All right, so my next example where I'm doing the same thing, all right, doing it for a couple examples here. We have the square root of negative 5, and I'm again asked to rewrite this as a pure imaginary, right? Square root of a negative, and I'm asked, what's the principal square root of negative 5? So again, my little rule earlier, I'm just going to simply rewrite this as the square root of positive 5 times I, right? Times that imaginary unit. And this is it, because the square root of 5, yeah, that's real. I have a real number times I, right? A pure imaginary here. And the square root of 5 doesn't simplify anymore. So I can write this as, square root of 5, and then with the I after. Again, make sure it's after, not underneath. Don't make this too long. It's just the square root of 5 and then times I. And then again, usually to avoid that possible mistake, very often the letter will be thrown in front as the first factor. So I times the square root of 5. All right, which again, I'll most likely be writing things this way, just just so I can avoid making the possible mistake of making that square root too long and then thinking the I is underneath the square root when it's actually not. All right, now I'll do a check here, right? Is I times the square root of 5, is that the principal square root of negative 5? Well, let's square it. So I times the square root of 5 would be, when you square it, you'd have, I squared times, and then the square root of 5 squared would just be 5. Right? And then I squared, remember I is that number that when squared is -1. Right? It's the principal square root of -1. So then I have -1 times 5, which is indeed -5. So yes, I times the square root of 5, or the square root of 5 times I, is the principal square root of -5. Great. All right. So I've got one more of these where I have the square root of a negative real number, and I'm asked to rewrite it as a pure imaginary, right? A real number times this I. So the square root of -12, and square root of a negative, it's going to be a pure imaginary. And very simple, just this, it's just the square root of +12 times I, right? Times that square root of -1. Okay, and then of course we need to simplify the radical. Remember the square root of 12, I'll do this off to the side. Right, when you're simplifying a square root, right, you got to think of perfect squares that are factors of the radicand. Right, now 12, a perfect square that goes into 12 other than 1 would be 4. Right, that's 2 squared. So that's the square root of 4 times 3, which, using the product property, you can break this up to the square root of 4 times the square root of 3. And again, the only reason you can do that is because the square root of 4 and the square root of 3, those are real. Remember, the product property is only for real numbers, and I'll discuss that in further detail in an upcoming video where we're talking about these imaginary numbers and complex numbers with an imaginary part. And what is the square root of 4? The principal square root of 4 is 2 times the square root of 3. Right? So when I simplify, sorry, that's a 3. So simplifying the radical, the square root of 12 is 2 times the square root of 3, and then I have times I afterwards. Again, this is totally fine, but very, very often they'll put the variable factor and all the non-radical factors in front of the radical factor. So instead of 2 times the square root of 3 times I, just rearrange them, and you can have 2 times I times the square root of 3. Right? Or again, usually the non-radical factors are put in front of radical factors. Right? I'll put this in a box here. Right? So there is the principal square root of -12. And this time I'm not going to check it, but if you want, you can raise this number to the second power. Then you'd have 4 times I squared times 3, which would be 4 times -1 times 3, which would indeed be -12. Right? I'm not going to write that out, but this is indeed the principal square root of -12. Okay. All right, so my last several examples have to do with complex numbers. Again, my last video I put up where we talked about the system of complex numbers. I'll refresh your memory again. The complex numbers are your real numbers, your pure imaginary numbers, and really any number that you can think of. Any number that can be written as a real number plus a pure imaginary number. All right, so basically everything we can think of in an intermediate algebra, pre-calc, calc 1 class, every number we can think of is a complex number. So here's what I'm talking about here. Right? What I'm asked to do in my final 3 examples is to write each expression, write each number in what's called the standard form of a complex number, this a plus bi. All right, so what is this? All right, so let's, again, a little recall here. Talked about the complex numbers in the last video I put up. I'll refresh your memory here. All right, what are the complex numbers? Well, it's a set of numbers, right? So a set, and every single number in the complex numbers can be written this way, where you have a number a plus and then a number b times I, such that a is real and b is real. Right? A and b are real numbers, right? So they're either rational or irrational. So really what you have here, right? So every number that can be written as a real number, this a, plus a pure imaginary, right? The bi, real number times I, that's pure imaginary. So any number that can be written as a real number plus a pure imaginary number is considered complex. And what we saw last video and what you're going to continue to see is that every number we're going to deal with is complex. All the real numbers are complex. All the pure and imaginary numbers are complex. And any number that is basically a real number plus a pure imaginary. All right, and then very often too, this number a is maybe called the real part of a complex number, and the number b that's attached to the I, the imaginary unit, is very often called the imaginary part of the complex number. All right. All right. So look at what I have up here. All right. I have the number 4 plus then this square root of negative 100. All right. So as I mentioned before, whenever you see the square root of a negative, you should be able to rewrite that as a pure imaginary. Okay, so this is equal to 4 plus, and then this square root of negative 100 I can rewrite as the square root of positive 100 times the imaginary unit I, right, times that square root of negative 1. And then simplifying radicals here, I'm seeing the square root of 100. The principal square root of 100 is 10. Right, so this is 4 plus and 10 times I, or just 10I. And this is exactly in this form here. Don't put the 4 and the 10 together. This is not 14I, right? It's just like, again, we're going to treat I like a variable a lot of times. This term does not have an I attached. This term has an I attached. So you cannot put these together. These are not like terms. So this is as simple as this would get, right? Nothing can be combined. And this is in this form where the value of a, the real part of the complex number, is 4, and the value of b, right, the imaginary part of the complex number would be the 10, right? A plus bi, 4 plus 10i, right? A real number plus a pure imaginary number, making a complex number. Right. Great. And I should be able to do this with any number I see. Any expression with numbers I see, again in an intermediate algebra, pre-calc, calc 1, calc 2 course, I should be able to rewrite in this form, this standard form. So my next example, very similar. I have a negative 2 minus then the square root of negative 8. And as I've mentioned, whenever you see the square root of a negative, automatically you should be thinking, I should rewrite this as a pure imaginary. Okay, so this is equal to, negative 2 I'm not doing anything with yet, minus, and then the square root of negative 8 as a pure imaginary would be the square root of 8, positive 8, times the imaginary unit I times the square root of negative 1. Now the square root of 8, I'll do this off to the side. You can break that up to the product of two real numbers. The square root of a perfect square, 4, times the square root of 2, right? 4 times 2 is 8. And square root of 4 is 2. So the square root of 8 is equivalent to 2 times the square root of 2. So what I have here is, negative 2 minus, and when the square root of 8 is, simplified, that's 2 times the square root of 2, and then, times I afterwards. All right. And this can be rewritten in all sorts of ways. you know, this is you could write this, you know, that's -2, the real part, right, the real number, and then, you know, plus, if I truly want to write it as this a plus bi form, like they're asking me to, right, the real number a is -2, and then subtraction, remember, is just adding the opposite. So when I see, you know, this -2 times the square root of 2 times I, that's the same thing as plus, and then, you know, -2 times the square root of 2 times I. Right? So you could rewrite this way, means the same thing. So you see the real part, the real number here for a is -2, and the imaginary part of this complex number, the b, is this -2 times the square root of 2. Right. So, you know, this is how they asked me to answer it, but again, I could write this in all sorts of different ways. You know, going back to here, we could also write this as -2, and then throwing the, you know, this factor of I in front of the radical, -2 times I times the square root of 2. All right, all these things, this and this and this in the box, they're all the same. Okay, they're all the same. It's just that the one in the box is actually in the form that was, you know, asked of us, the a plus bi. But each one of these is a real number plus some pure imaginary number, right? A real number plus some pure imaginary number. Great, and that's all I'm asked to do there. And then I have just one last example where, you know, we have a fraction. And where again I'm asked to take this fraction here, the, you know, the numerator is 6 minus the square root of -72, and the denominator is, you know, 3. And I'm asked again to rewrite this as that, you know, a plus bi, a real number plus some pure imaginary number. All right. So as before, as the last several examples now, I see the square root of a negative. Please immediately think I should rewrite that as a pure imaginary number. So there's 6 minus, and then the square root of -72. I'm going to rewrite as the square root of +72, right, a real number, times I, right, times the imaginary unit I. And there's the square root of -72 rewritten as a pure imaginary number right here. And then all this in the numerator divided by, you know, 3 in the denominator still. Okay, and then off to the side we'll simplify the radical, right, the square root of 72, right, it's real, right, and I can break this up into the product of two real numbers where one of the radicands is a perfect square. You know, 36 goes into 72 evenly, and that's a perfect square. So I could break this up to the square root of 36 times the square root of 2, and the square root of 36 is, you know, 6. So 6 times the square root of 2. So let me rewrite that radical that way in the next line. So we have in the numerator 6 minus, and then the square root of 72, as mentioned, is 6 times the square root of 2. And then we have times I, you know, again afterwards. And all this is being divided by 3. And I'm just going to use the rule now where, you know, if your numerator has multiple terms like this does, there's this real term and then this pure imaginary term, you can divide every term of the numerator by the denominator, right? It's basically just like reversing the addition of fractions or subtraction of fractions. So this is equivalent to the first term, 6 divided by 3. Then minus, you know, minus, and then the next, you know, 6 times the square root of 2 times I divided by 3. And then we can simplify, right? We can simplify each of these fractions. In both of them, you know, the first term here, 6 divided by 3, that simplifies to simply 2, right? Then we have minus, and then again here I have 6 in the numerator. 3 in the denominator, right? They have a common factor of 3. So the 3 would divide out, the 6 would become, you'd have a factor of 2 left over. All right. So I have 6 divided by 3 is 2 for the first term. Then the next term is minus, and then what I'm left with is factors of 2 times the square root of 2 times I. All right. And then if I want to rewrite this in the form that was asked for, right, the real number, the real part is the number 2, then plus, and then the pure imaginary number is negative 2 times the square root of 2 times I, right? So the real part of this complex number is 2. This imaginary part of the complex number is negative 2 times the square root of 2. And this is the form that they wanted. But again, I could write it this way. This isn't drawn down here. Or I could write it where I have 2, then minus, and then again throw the I in front of the radical, 2 times I times the square root of 2. That is fine as well, but the specific form they asked for was the A plus BI form. All right, wonderful. But so the keys to take away from this video, one, whenever you see the square root of a negative number, immediately think, I need to rewrite that. I should rewrite it as a pure imaginary, a real number times I, right? The square root of the positive times I. 2, I is that imaginary unit, right? I is the principal square root of negative 1. So if you ever see I to the second power, I squared, that's negative 1. And 3, right? Every number that you see, every number you come across in an intermediate algebra up to Calc 1, Calc 2 course, every number you come across, and even beyond those two, like most courses, every number you come across is a complex number, which is a number that can be written as a real number plus some pure imaginary, right? A real number plus, and then a real number times I. Okay, you should be able to write any number like that. Wonderful. All right, and as I like to say at the end of these videos, do the best you can to try to learn material on your own before you go looking for help. I have found that people who take the time and the effort to learn something on their own, tend to remember it better and remember it for longer and are more proud of it. So of course, read the material, read through the author's examples, perhaps even try to work out the solutions to an author's example before you see how the author did it, and then compare your work to the author's and see if you can learn from some mistakes there. Obviously, work on tons of exercises, practice problems, look up solutions to those if they're made available so you can check yourself, keep track of your progress, see how you're doing. And don't just give up on a problem after the first attempt or two. Don't give up so easily. Very often in mathematics there are several approaches that'll work for any particular problem. So if after several attempts at a problem you're still not getting it, perhaps you should go back and read the material again, maybe even a third time, more slowly, more deliberately, take good notes. Because if you've been working on some problems, there's a good chance you have a better idea as to what the author wants from you, what the author is asking you to do. So then when you go back and read again, you'll have a better idea as to what to look out for in the reading. And some things might pop out at you that didn't the first time through, and give you better understanding maybe, and you'll work on the problems a little more easily, hopefully. Right. But if after that, if after several read-throughs of the material and several attempts at problems you're still not understanding, then it's not a sign of weakness whatsoever to go asking for help. That is what other people are there for helping, right? To help you. So ask a teacher, a tutor, a friend, someone in your class who knows the material well and is willing to help. Look for supplemental materials online. There's loads of it out there. Look for videos on the subject. There's tons of those too. Videos like this one, or plenty of other ones out there that are better than this one. I assure you they're easy to find. But just keep at it. Keep practicing. Stay persistent. Don't give up. And above all, and I believe this is the hardest thing, is to keep believing in yourself and in your abilities. Have a positive attitude toward the subject. Even through your struggles and failures, because it's in those times of struggle and failure that you can learn the most. If you just keep at it and try to, do what you can to fix your mistakes, you learn from those mistakes. And also it sticks in your mind better when you learn from your mistakes as opposed to getting it right on the first try. You actually seem to care more if you stay at it during your struggles and keep going until you get it. So keep persistent, keep practicing, stay positive, and don't give up. And I just know you'll get it. And thank you very much for watching.